Hello, good afternoon everyone. So today we are going to collect some information of chemical kinetics, which is a very important branch in physical chemistry, and day by day in every sector of life it is having its importance. So let us start with the definition of this term, chemical kinetics. So whenever we say chemical kinetics, definitely it is connected to the chemical reactions, and here we have to observe the rate of the chemical reaction. Number second, we have to observe that which are the factors that are affecting the rate of reaction, and number third, we have to see the mechanism or the steps that are involved in the chemical reaction. So these are the 3 points that we have to focus on in chemical kinetics, and therefore overall we say that it is a study that deals with the rate of reaction, the factors affecting the rate of reaction such as temperature, pressure, concentration, then catalyst, light, etc. And the mechanism, that means number of steps that are involved in the chemical reaction, whether the reaction is taking place in one single step or whether that reaction is taking in more than one steps. So that is the thing that we have to learn under this particular part, that is chemical kinetics. And then we are going to move to the first part of it, and that first part or that first term that we should know, that is the rate of reaction. And whenever we talk about the rate of reaction, that time we say that the rate of the reaction may be defined as the change in concentration of reactants or products per unit time. So that is the thing that we have to keep in mind regarding this rate of reaction, that it is the change in the concentration of either the reactant or products per unit time. So that is a simple definition of this rate of reaction. For example, here we have to keep in one thing in mind, that whatever we are talking here in terms of kinetics, chemical kinetics, it is related with the concentration of reactants only. That means focus is given on the concentration of the reactant. Now let us take one general example. For example, let us take a general reaction, say reactant A, that gives the products, that is B. A that gives B. A is the reactant here, B is the product here. Then as the reaction proceeds, so we say that as the reaction proceeds, we are observing that the concentration of the reactant decreases and the concentration of the product is increasing. For example, here if you start the reaction at 1 o'clock, so that time we are observing that the concentration of the reactant is more. But as the reaction proceeds on, and when we are observing that reaction after 15 minutes, that is 15 minutes past 1 o'clock, that time we are observing that the concentration of the reactant has increased, and therefore this change of concentration of reactant and the product per unit time, again here it is referred as the rate of reaction, but here in this case we are observing that there is decrease in the concentration of the reactant, whereas there is increase in the concentration of the product. So that change we are observing here as the reaction proceeds on, and if you are observing that particular reaction after a certain interval of time, we are observing this particular part, and therefore we say that the rate of reaction depends upon the concentration of the reactant. And then we go to the latter part, and here we say that if dx by dt is the small change in concentration with respect to time, that time we write it as dx by dt is directly proportional to the concentration of A. And again finally we go to the last part of it, that dx by dt may be equal to small k into concentration of A, where k is the proportionality constant or the rate constant or the velocity constant or the hydrolysis constant. So in this way, this is the short information that we have collected regarding the rate of reaction where there is change in the concentration of the reactant or product per unit time. So we will stop here only, and we will be collecting the other information in the next part.